So today I've got my Case DC4 hub with 3 broken off bolts up on the Bridgeport table here. I don't know what size these are exactly, as they're pretty rusty, and we looked up the diagram on Massix, which is one of the bigger Case IH dealers in the area. They have all kinds of like old parts diagrams and stuff for stuff like this. They have the hub listed on there. They don't have the bolt size listed on there. They have all the bearing numbers and stuff like that for the hubs. The race for one of these bearings is like $62, so that's why there's a rag in there, keeping that all clean. It's got grease on it still, but I stuck a rag in there so we don't get any chips down in there and scratch that. And it keeps the grease in there so that it doesn't rust, because it's been a week or two since I've had this off, and I haven't been able to get around to fixing it. But today, what we're going to do is we're going to mill these off flat with an end mill. I'm going to center drill them, and I'm going to run a 1/2 inch drill down through the middle of them. And if I don't see any threads yet, I'll run a 9/16 drill down through, see if I see any threads, and I'll keep drilling them out slowly, progressing each tap drill size until I figure out what the threads are. I think they're 5/8. I thought they were 3/4 at first, but I'm pretty sure they're 5/8. But a 1/2 inch drill will give me a safe margin of error to start with, in case they are some weird in-between size. Because on older stuff like this, there wasn't as much of a standard at that time. So it could be something weird. Let's get right into it. So as you guys can see there, it drilled the top just fine. Once we're getting down in here, it isn't drilling so good. Now, some of you guys are going to say, hey, you're using oil on cast iron. Well, the hub's cast iron, but the goal is not to machine the hub. The goal is to machine the bolt out of the hub. So, could the oil be hurting me? I suppose a little bit if I wasn't on center, but that doesn't seem to be what's going on here. I don't think that's what's happening. So I'm going to get a small little end mill, a carbide one, because maybe it's work hard and maybe somebody already tried heating them up and getting them out and just got them hot and hard again. And this doesn't feel hot out here though. Regardless though, I'm going to find a 1/2 inch carbide end mill, hopefully a center cutting one. That's why I had to drill the top off and mill the burr off, because the end mill I have here is not center cutting. See the little circle in the center? There's nothing there cutting or removing material, so it'll leave a little dimple in the middle, and then it'll scream and throw sparks, as you saw a little bit there. So we're going to get hopefully a center cutting one, if I can find one, in one of the toolboxes in here, and we're going to cut that out, plunge cutting, now up and down like I'm drilling, but with an end mill instead. Because carbide will put up with a lot more heat, a lot harder material, but the heat, and sometimes they don't like heat so much, so we'll try to keep it cool. So far that was working pretty well, but the edge of the quill here was actually hitting my clamp. But I'm down in there about 3/4 of the way through this plate, or this flange I guess you'd call it. And I'm just starting to see threads on this side. I can just see a couple threads poking through. So what I'm going to do is I'm going to move over about as far as I think the hole should be for the thread size. I've got my DRO zeroed here. I'm going to move in the X about 50 thousandths, and we'll go 75. I think 75 will do this. And I'll run down in there again like that until it bottoms out on here, or I may see threads before then and I'll stop. And when I see threads, then I can figure out about how big it should be, and I can get in the center of it. And then I can get in the center of it this way, and then I'll be able to get the right size tap drill down in there and clean out whatever's left. But it was cutting much easier once I got further down in there. I'm thinking the reason the drill wasn't working is because it was work hardened from, I don't know, whatever reason. My drill's relatively sharp, but it's not like razor sharp. So that could be it. Or these could just be really good bolts from way back in the day, because this may have never come off the hub before. It's hard to say. So I've got some threads exposed now, and I can actually take a hammer and a screwdriver and pick the threads out of the hole. Get a couple pieces there. Is that the best way? No, probably not. Does it work? I don't know, it seems to be so far. Or it's at least a starting point. I generally do this on a smaller scale at work. But there is a chunk of our bolt that I've milled down through the center of. And the threads in the hole look like they'll clean up so far. I'm going to try to pick a few more of these out, and then maybe I'll have to go back in with the end mill. Yeah, I think I'm going to have to go back in with the end mill, but we've got a starting point. When you get a starting point, then you can grab a hold of something, and you can go forward with it. So with some figuring with a thread gauge, looking at what tools I have available, which is minimal that I know where they are. Because it's Grandpa's shop and Grandpa knows where everything is, but I haven't figured out where everything is yet. We're using a 5/8 11. It's what size came out correctly when I checked it with the gauge. We're in tab at 5/8 11. Which makes sense because they were 15/16 bolt heads. But on some of this old stuff, they had oversized heads on stuff, or undersized heads. The standards weren't really set in stone. They were like suggestions. Because this is an early 50s machine, they were still kind of a little sketchy on the standards thing. I don't have a tap drill. I don't have a 17/32 for 5/8 11. I do have an end mill, it's a high-speed end mill, 4-flute, that has been reground and is about 535 thousandths. And the tap drill for this tap, which is 17/32, is 531. It's close enough. It's not a race car. It's not going 100 miles an hour. It's a tractor front tire. and all it's got to do is clamp the rim to this hub. That's all it does. It just squeezes against there. And the other two, being that I know what size they are now, I can drill them, and these ones are a little better to work with because this one was up above and it was mangled. It was hard to find the center of it. These two other ones, I can find the center of them because there's a nice ring of steel around there, so I can get centered up on them better, so the threads will be better in them. Whereas this one, I kind of got into the side a little bit. But it's going to be better on the next two. And like I said, it's not going 1,000,000 miles an hour. It's not going 1,000,000 miles. It's going to be just fine. So we only have good land in there for threads the whole way around. About the last, probably the last half an inch of this, which is not ideal, but it will work. And if I'm really concerned, I can use a longer bolt and put a nut on the back of it, and then it doesn't really matter anyway, because these are through holes. They do go clear through, but at the time it was easier to tap this than it was to put a nut on the back. But we'll use a nut as a safety measure on this hole, because this is cast iron. As far as I know, Case did a lot of casting, especially iron at this point, and cast iron doesn't weld super well. I've got some tricks for doing it, which we'll get to that in a later video, and I've done some other little tricks in past videos, but I didn't get a lot of footage of the actual welding process. But I will in the future on this DC project actually show you some cast iron welding tricks. But going in and welding it and then having to go in and thread it is a different thing on cast iron. I have not perfected that yet. So we're just gonna use the nut as a safety measure and see how good the rest of these holes go. So I was not able with the Bridgeport to get down, at least I didn't feel comfortable getting that close to this clamp with the face of this, and I didn't have enough tap sticking out. So I just got a few threads started in the top. And as I'm running this in with the wrench here, it's actually pushing the broken bolt out the bottom, which is kind of good, but also kind of bad because I milled some of it out too far on the diameter. And so there's not going to be a whole lot of threads in there to catch, and it just popped out the bottom. But I'll show you guys what the threads look like, and hopefully the other two ones of these go a little more normal for you guys to see how this is supposed to work. Make sure I get this all the way down in there, because the bottom of a tap, unless it's a bottoming tap, which this is not, the threads aren't as, they don't stick out as much way down there because you're trying to start them into a hole, so they're tapered. So I want to make sure I get I got the taper part clear down through there. And is this the right way to drive a tap? No. I don't have the right size tap wrench to run a tap this big. Square drive sockets also work really well. If you have a set of square drive sockets, or 8-point sockets, they work really well. You just got to find the right size that fits your tap. I'm amazed that this tap pushed that out, but the giant drills I was running in there did not. So on the far side here, there are no threads at all. But by the looks of it, the other 75% of that hole, a little more than that actually, have threads in them. So I think that's going to work. So basically, a little more than that much of the hole diameter, or circumference I guess you would say here, has good threads in it. There's a little bit over here basically that does not, because I got into it a little too far off to the side with that end mill. That's a trophy right there. I'm not going to throw that in the scrap bucket right at the moment. That's one to go home and show mom and dad what the heck you spent all afternoon doing. Because I expected this to be a 2-hour project, and I'm, well, 3 hours into it, and I only have one hole sort of fixed. But I have a plan now. I have tools found. I know what size it is. So now we just got to roll with it. So what you guys just missed from the camera moving, because the light fell on it, the cutter sucked into something and scared me pretty good. It caught some of the bolt and ran it out the bottom of the hole. So that's good, so we don't have to cut new threads, because it actually cleaned out most of the old threads. Now all we got to do is get the tap in there and chase them, which is way better than cutting new threads in a hole that already has some threads in it. Because when you end up with a set of threads that start here and a set of threads that start over here, then you've got two sets of threads that are crisscrossing. Chances of cross-threading way higher, and it's not as strong because there's not as much steel, or cast iron in this case, in between the threads. You can see the threads from here. Hole 2 was a success. Let's see if we can make hole 3 better yet. I got you guys right up there in the front seat now, looking at it. It's right up there in your teeth. You can look at it. There's what we got to work with for this third hole. And you guys will have a much closer view this time. Where you guys were at before, you couldn't really see what was going on. Super close, but now I got you in there sitting behind the table on the ways of the Bridgeport. Hope you guys like that I can move it around and get a little closer look at what's happening here. Time for the center grill. You guys moved a little bit on me when I was adjusting cable height. Switch to lower range for this drill, because bigger drills, they just run better in lower range. If you're having trouble with a bigger drill, 1/2 inch or bigger, I would say to start with, just slow it down on the RPM a little bit, and you'll generally be surprised, unless you're drilling something other than steel. Aluminum and stuff, it's a little different. But for steel or iron, it's best to just slow them down. From my experiences. little toasty down there, so I'm not gonna go poking around in that hole just yet. I imagine it's just fine. What I can see from up here looks pretty good. Normally I don't like to leave too much end mill hanging out of a collet, but in this case I have to get as much end mill sticking out as I can, safely do anyway, so I can get clear down through the part. I wonder if I picked the right location, because being this is a 3-bolt hub and there's not a ton of information on the internet about these. I don't know the pattern. I could have guessed. I could have looked it up probably, but I was expecting to have to completely drill new holes somewhat. So I think guessing was close enough. Hopefully from this view you'll be able to see when those threads grab and spin out of the bottom. Well, assuming they actually do that. I kind of hope they do, but it was kind of scary when it happened. I gotta slow this way down. And there it was. That was pretty scary. You can see a little bit of it sticking out of the bottom there. I don't know if you guys can actually see that. So I'm going to go back in and bump it again and see if it'll go. But that's pretty scary at 700 RPMs moving at 11 threads per inch. Pretty scary. Slow it down as high as I can go and high, or low as I can go and high. One again. That was still pretty scary at 500 RPMs. Oh yeah. Look at that. Might have to go in and bump it again. Because it just isn't quite let go yet. Easy does it. There we go. Right there. Worked out pretty good. I'd say I got relatively centered up on that hole as well. Let's see how the tapping goes here. I gotta move the table again, so I got room to get the tap and the handle in there, or the wrench in this case, and to get the tool out of there without slamming it down into the part when it breaks loose, because that's never fun. I don't know where my wrench went. I've lost my wrench. Oh, I put it on a different bolt this time. You'll have that. Here's one thing that I don't know if any of you machinists out there that are watching me, if there's real machinists watching me or tool makers, they probably have quit watching me by now, because I don't do things the normal way. I do when I can, but I don't have the ability to at the moment. Why is every bolt on a Bridgeport take a 3/4 inch wrench, or 19 millimeter for you metric guys? Except the bolts that you use to hold the vise down. they're 7/8. Does anybody know why? So I've always wondered that. I've asked the guys I work with in the tool shop why, and they're like, I really don't know. It seems kind of strange to me, but I want to know what the thinking was there. Because I love the fact that every bolt is 3/4 inch wrench, so if you have to adjust anything on one, with the exception of the vise or a turntable, you use a 3/4 inch wrench. Or if you have a foreign knockoff Bridgeport, it's 19mm generally. Why not the vise bolts? It would just make sense. Then you need one wrench to work on the machine, with the exception of a few little things here and there. Of course, electrical stuff, some of the gear drives inside the head. But all the external adjustment bolts are pretty cool that they're the one size, so you always know what you need. Those threads feel pretty good. They're a little crunchy, but pretty good for doing what we did there. I'm pretty happy with how this went. The first hole was a little sketchy, but these other two holes have me feeling better about this. And I will be putting a nut on the back of that first hole just for safety purposes, because I hate to be driving it down the road to the tractor show, or pulling up to the sled, or going down the track even, and the wheel just decides it's not going to hang on anymore because it's been riding around with 2 bolts holding it, and break something or blow a wheel bearing off because it was shaking or something while I'm driving it. Yeah, those threads in there look pretty good, considering what they were. You can see we got not perfect threads. Not bad. This is the little bit sketchy one. See, on the far side there's not so good, but there are a few good ones in the bottom. A little dirty yet. Over here went about as good as I think it could have. Getting that nice coil of threads out of there. I mean, what better can you do? That's why I got you guys. Tell me what I can do better on this project, besides buying some of the right tools, or finding some of the right tools, like the tap drills and some better end mills maybe. Good as new. Got the wheel bearings repacked. Got that snugged up on there. And it's ready to roll again. Now I got to wire brush up the rim, and I'll take the wire wheel and clean all the rust out of it, and we can put the tube on it, the new tube, and put the tire back on it, and then we'll be able to roll it into a building to work on it. Thank you guys for watching. If you made it this long and you like what you see, make sure you hit the like button. Let me know that you appreciate seeing videos like this, and make sure to subscribe, because there's always little machining projects similar to this around the farm that need done, and if you guys are interested in seeing them, I'd love to show them to you. Once again, thanks for watching, and have a great one.